Hey team, I'm Alex and welcome back to the channel. So we left the last episode with the engine stripped and inspected. So now let's get it back together to a position where we can try and get it started. So first up, let's focus on the main body of the engine, and rebuild starts with the valve lifters being put in place, followed by the camshaft, and the camshaft is secured by that long dowel. The valves then drop into place from above and the springs and cotter pins fitted to secure them. Okay, so let's just check that the valves work. If you remember last time, the intake seemed okay, but the exhaust was seized and jammed. So we put it in with the springs and so on. So I'm going to put my hands in and turn the camshaft by hand. And there we go, there's the exhaust. Sorry, the inlet, looking fine. It's a lot stiffer. There we go, there's the exhaust. In, out. And that's a lot better than we had before. In, out, and the end coming up again, and that's all good because see the exhaust spring on the left is much thicker than the inlet spring, so it's a much harder valve to open, but that's all good, so valves work. Or so I thought. After fitting the crankcase ventilation spring, I checked the valve clearances, and they were not to spec. Okay, we've discovered a minor problem here with the lifter to valve clearances. This is the inlet valve, and that gap there is 7 thou, or should be 7 thou of an inch, and it is exactly, so that's good. The exhaust gap needs to be 15 thousandths, and it's in contact at all times. So that's a little problem, which means the exhaust valve is going to have to come out, and I'm going to have to shorten it at the stem by probably grinding on a whetstone or something. I'll see what I can do, but that's got to have a really thin sliver taken off it, such that there is a gap between the lifter and the base of the valve. So, right, well, I've got the exhaust valve out. This needs to be shortened by 15 thousandths of an inch, which is 0.38 of a mil. I did blue it up to try and scribe the line, but it's such a small dimension I couldn't actually do it that easily. So I've devised another way. I'll just measure it after I've cut it, ground it. So what I'm going to do is, if I can just do this, I've got a V-block. I'm going to put it in the V-block like that, and that will be screwed down to hold it in place. There we go. So the valve will be held there. On this edge of this table is a machine face surface, so that will be held flush to that. And I'm going to move that inwards towards my grinding wheel and just cut it off, grind it slowly, and just touch it until I've got the required material removed. Okay, so it's all set up. It's nice and square. So this is just going to be in and out now into there. Let's give it a whirl. So the original valve length was 2.8275 inches, which makes the target length 2.8125 inches, and 0.015 thou isn't a lot really. So the first grind reduced the length to 2.827, so I only just touched it. I gave it another go and got it to 2.8175. So I stopped there to check in the engine, and I was glad that I did. It's going to be a little bit fiddly to do, but I've got 15 thou on here, and it goes under there just sweet. There it goes in. So that is a gap. There's the 5, and underneath the 5 I got a 10. A 15 thou and a 20 thou won't get in there. Mission accomplished. And with that done, fitted the valve chest cover plate and moved on to the crankshaft. Okay, ready to fit the crank. Now timing is important because it's all gear driven, between the gears here on the cam and on the crank. Now if you look carefully, here's a little ding there, a little mark. That's your alignment mark on the camshaft. On the crankshaft, you can see it there on the casting. It's there. So you've got to align those two up when you're inserting the crankshaft. So that's my challenge. I should be able to do that. And then that should mean that the inlet valve will open at somewhere between 22 and 24 degrees before top dead center. And apologies for the poor highlighting, but you can see right in the middle there where the two marks are aligned with the crankshaft fitted. And with that done, we can now fit the piston. It's got new rings fitted, and it's the straightforward job of compressing the rings with the ring compressor and just tapping it in down the cylinder until it's in place. And all that's left to do is torque down the bearing cap together with the oil splasher. Then the sump can be fitted together with the cylinder head, and that's the main body of the engine built. Time now for the ancillaries. So let's make a start with the exhaust, where we have a broken pipe to address and also the silencer box itself. This rusty relic was opened up, the old wadding was removed, which was in itself rather amusing. Given a good old clean up, there were a couple of pinholes which we fixed with some JB Welds and got it all ready for paint. For the paint on the exhaust box, I chose Nitromorse barbecue paint. That paint is rated up to 650 Celsius, plus it has a nice matte black finish as well, which is quite nice to go on the exhaust. For the exhaust pipe itself, I decided to make a new one out of a piece of 1-inch hex bar that I had to hand. First stage would be to face it off, give a nice flat edge here, which will essentially be this edge here. Then I'm going to actually put it in the mill, and I'm going to drill these holes. I can take advantage of the flats. Much easier to get a drill going in a flat than it is going through a round. So essentially I know the thickness of this steel bar, so I can drill through it. One's a through hole and two of them either side are just halfway through. So that's easy enough to do. So I get those through holes drilled for the exhaust to vent into the baffle box. All right. Then once that has been done, back in the mill, this is then going to be turned down to about here, maybe a little bit more, to the right diameter to allow me to cut this 1/2-inch BSP thread. So I'll turn it down, then I'll cut the thread and do a test fit in the engine block. That should all be fine. Then essentially I'm going to drill this through hole. There's a hole all the way through, obviously for the exhaust gases. So I will then drill through to this depth inside the hex bar. Once that's done, I'll normally flip this over in the lathe and tack it from this end, and I'll machine this diameter for the part which sits inside the box, and then I'll machine this smaller diameter here for this 1/2-inch UNF thread. Then I'll cut that thread, and then I'll just essentially shorten it to length. And I thought I was going to have a fight with the thread, but I was wrong. Cut it like butter. I was so pleased with that. So the moment of truth. Let's give it a whirl. That should screw in. Look at that. There you go. Perfect. That's the through hole drilled. 1/2-inch all the way down. That's good. So that's that done. Down to dimension. So the exhaust plate fits on it like that, which is perfect. Okay, so that's the thing machined, ready to have a thread put on there. So there you go. Exhaust fits on like that, and then the nut will hold that in place. And there it is, done. Unfortunately, with that done, it all goes together and it fits just fine. I removed all the hex in the end of the bar just to leave the round bar as per the original piece. And the last stage is to fit fresh baffle material. So I used a piece of motorcycle exhaust pipe wadding, I cut it to size and packed it in the box. Then a final blow over of paint, and that's the exhaust complete. Time now for the carburettor, which is a Zenith TCA2 model. It's relatively simple in construction with only 24 parts, so a very, very simple job to disassemble and to clean. Very good, team. That's a carburettor. Stripped, cleaned, ready for reassembly. All the parts been polished and cleaned up as best I can. A couple of issues that we've got to deal with. The float here, the needle is not straight with the recess at the back, the other point, so it's bent basically. You can probably see it there. If not, I'll stick a photo on to help identify that. And it's a bit bashed, so may well end up replacing that. I can try and straighten it, but it won't be, perfect. And the other bit here, this part is twisted. If I can just get it on camera. And you see the twist in it? Oh, that will not do. So this is 3/16 thick brass. So I've got someone who will make this. It's not too challenging to make. So I can make one of those, which would be awesome. And then I just need a couple of split pins. So all in all, that is a little job done. Good. I ended up replacing most of the internals of the carb rather than attempt to make myself, and then reassembly followed the illustrations in the mower manual. Starting with the bottom portion of the carb that has the fuel bowl in, I fitted the choke assembly that opens and closes, that moves very smoothly, and then the slow running tube that pulls fuel up from the bowl, and the first of two adjustment needles. Drop in the float bowl that has a little recess that it sits in, and that's the bottom of the carburettor built. Moving to the upper portion of the carb, the first part to fit is the needle seating that the float bowl engages with to shut off fuel flow when the bowl is full. Then fit the throttle butterfly and air regulating screw. Finally, the tickler is installed that is used to flood the carb by depressing the float bowl, and that is used for cold start. You then bolt the two halves together, add the main fuel inlet banjo at the top, and the carb is complete. Let's now move on to the ignition system. This is a simple crankshaft-driven coil and points arrangement that provides the HD voltage for the spark plug. An initial inspection showed the coil unit itself has burnt out, and also the HT lead was looking somewhat worse for wear, so replacement coil and lead have been ordered. Replacing the coil and HT lead is a straightforward operation, together with adjusting the points gap. And that's all there is to the ignition system. So now to go and get things painted. I wanted a paint colour sympathetic to that used by Suffolk, and had some original paint left on the engine before I stripped it all off. So I got that taken to a local paint supplier to get a colour matched, and then I did a little test piece which worked very well. With the paint chosen, the engine was initially primed using 2 coats of acid etch primer that is heat resistant up to I think 250 Celsius. And once that had cured, then 2 coats of the C71 Speedline top coat were applied, and then the engine built up with the carburettor, the ignition system and the exhaust fitted. So it's all starting to look the part. For the fuel tank and cowling, these do not need heat-resistant paint, so they were stripped back and then primed red oxide. The final colour will be a bright red, which will be applied once the engine is up and running, as things tend to get marked and dinged and bashed about a bit whilst other build activities are ongoing. And that's where we have to leave it for now. I do hope you've enjoyed this video, and if you've got this far, please like, comment and subscribe, and I'll see you at the next episode. Thanks for watching.